Hi, I am Renesas RA from Product Marketing team here at MathWorks. In this video, I'll demonstrate how to configure the analog to digital converter block for Renesas RA Microcontroller through a hands-on demo where I'll be reading the on-chip temperature sensor data. Before getting into the hands-on, let's see the hardware connection. I have a RA6T2 microcontroller. Let's zoom in and focus on the SAI connector. Here is the pinout of the SAI connector and I have the FTDI chip with its pinout. Cross-connect the controller boards TX to the FTDI's RX and vice versa. Connect the ground pins together. Use the USB cable to power both the controller board and the FTDI. With the hardware set up, I have the Simulink model opened where I have the ADC block. Here is the block configuration where the stack name and scan group are specified to match the settings configured in the RA Smart Configurator. I am using a software trigger to initiate the ADC and read the results. So I have selected the trigger and read option. The ADC is triggered every 0.1 second as defined by the sample time. Once the configuration is complete, let me click OK. Moving forward, here is a C function used to read the sensor calibration data. In a similar way, user can integrate any custom code into the model. And then this section of model implements the formula which is used to convert the raw ADC counts to actual temperature data. Finally, a display is used to view the computed temperature value. Having understood about the model, now let's open the configuration parameter by pressing Ctrl E and go to the hardware implementation tab. Select the hardware board and the device series. Now expand the target hardware resources and here is the placeholder to include the XML file generated from the RA Smart Configurator which is used to configure the peripherals. For this demo, we need to set up the ADC and the communication stack to run the model in the monitor and tune mode so that we'd be able to see the temperature data back on the host computer. For that, you can either create a new RASC project by clicking on Create or locate an existing project if you already have one and launch it to view the settings. For this example, let's create a new project and launch it. Let's go to the stack and add a new ADC stack. Ensure to mention the same stack name in the ADC block configuration in Simulink. Once the RASC project is saved, the configuration settings are reflected in the generated XML, which was initially included in the Simulink during the project creation. You can then use Git stack info option to retrieve the ADC configuration details directly within the Simulink. Moving to other ADC settings, select the scan group 0 and select temperature sensor under channel selection of virtual channel 0. Since scan group 0 is being used, make sure it is enabled under the scan group settings. Again, ensure the same scan group is specified in the ADC block parameter in Simulink. Once the ADC configuration is complete, let's move on to the UART stack. By default, UART stack is added in the RA Smart Configurator if the project is created within the Simulink with the stack name RSAB UART channel 9 and the pins PD05 and PD06 corresponding to TX and RX pins of the controller. If the project is not created from Simulink, then user needs to manually configure all these settings as they are required to define communication between the controller and the FTDI module. Save the RASC settings by doing a quick Ctrl S. This updates all the settings in the generated XML file and let's now switch to the Simulink environment for the further settings. Under the connectivity tab, make sure the UART start name and the channel number matches with the settings in the RA Smart Configurator. Enter the COM port which acts as a device identifier for the communication between the FTDI and the host computer and it can be found under the Windows Device Manager. With all the configurations done, now let's run the model in the monitor and tune mode and observe the temperature sensor data in the host computer. I hope this walkthrough helped you to understand the basic settings required to get the ADC module up and running. Thanks for watching this video.